Hello everyone, welcome back to the channel, and today we are going to solve find special substring of length k. So here we are given a string of certain length, and here we need to find a substring of length k such that the next character and the previous character of that substring shouldn't be equal to any of the character in this substring. Again, all the k characters in this substring should be same. So let's understand this by a simple example. So suppose we are given A, B, A, and here we need to find a substring of length k is equal to 3, in which all the three characters should be similar and the next and previous character of those substring shouldn't be equal to any of the character in this substring. So let's say if we have substring of length k here, then the next character is B. We don't have any previous character, so we don't have to worry about that. So next character is B. So this is different from A. So this is our valid substring. So we will return true. What are the other valid substring here? So let's find out. What if we have substring as B? So here one condition is not satisfied because we have B as a different character among these two A's. So not all the three characters are same here. So what about this? Here also we don't have all the three characters same. What about this? All the three characters are not same again. What about this? So here all the three characters are same. What is the next character? There is no next character, so we don't have to worry about that. What is the previous character? So previous character is B, that is different from this A. So this is also a valid answer. So how can we solve this problem? So we can solve this in a very brute force manner, that we will initialize our queue, which will consist of all the substring characters one by one. So we will iterate through all this string. We will initialize our queue and we will iterate through all these characters. So let's iterate. So we have A here. So we need to check if our length of queue is equal to 3, then only we need to check of these three conditions. That means all the characters should be similar. Character which is immediately before the substring should not be equal to any character in the substring, and character after the substring should not be equal to any of the character in the substring. So if the length of this queue satisfied, that means the length of the queue is equal to k, then only we are going to check these three conditions. Okay, so length of this queue is still not 3, that means k. So let's move ahead. Second character is A. Okay, still not. So still length is not equal to K. What if we include another character? Okay, so another character is A here. So now the length is equal to K. So we can check if all the characters in this queue is same or not. How we can check that? So we can simply include all the characters in one set, and then we can check the length of this set. So length of the set would be 1, because this set would be equal to A only after removing all the duplicate elements. So let's say if we have A, B, C in this set, then set's length would be 3, which is not equal to 1. But we want set's length equal to 1, as we only want one single character's occurrence for k particular times. So all the characters in this particular substring should be similar, and the set size of this Q substring, so the size of the set, which should be equal to 1 only. Okay, so let's move to the next part. Okay, if we include B here, then we can see the length is exceeding k. That's not what we want. So let's remove A from here. Now the set length, now the size of this queue is equal to 3, but the size of the set would be equal to 2, which is not the desirable, because we want 1 as a set length, because we want all the characters should be equal in particular substring, which is not the case here. So let's move on. So let's include the next character A here. Again, we are exceeding the length from k, so we will remove this A. So here we are also getting our set length equal to 2, which is not a desirable behavior. Let's move ahead. Okay, so here again we are exceeding the set length, so we will remove this A from this queue, and we will again check the set length, which is here 2 again. That is not the desirable behavior. Let's remove this B and include last A. So here the set length is equal to 1, and then we have to check if there exists any previous element. If yes, then we have to check if that is not equal to any character in this set. Here the set will only contain one character, that is A, and we have to check if this B, which is previous of this set, is equal to A or not. If that is equal, then that is not the valid solution. If it is not, which is this the case, B is not equal to A. So this is the valid solution. So by this way, by doing brute force, we can solve this problem. But how to solve this? So this will cost us time complexity of n into k, because we have to go through each character in this string. So that would be n. And we have to create this set for k length substring. So that would cost again us k times. So for each character we are. So the first approach was our brute force using Q. So we have to iterate through each of the character in the string. So that would cost us n operations. And for each as each character, we have to create a set of length k. So that would again cost us k operations. So here we would get n into k as a time complexity, and space complexity would be let's say we are using queue of size length k. So the maximum elements in our queue would be k only. So except that we are not using any other variables, so our space complexity would be k only. Plus, we are also using this set of size k, so that would be k plus k, so that will be equal to k only. Yes, so can we improve this a little bit? Yes, I think we can. We can improve this time complexity to t of O of n and this space complexity to O of 1. Let's jump into that particular solution. So let's suppose we have string is equal to AA, BBB, and CC, and k is equal to 3. Uh, can we find a special substring of length k here, which has all the elements equal, as well as the neighbor element of that particular substring should not be equal to that any of the character in that substring? I think yes. So here we have b as a special substring. But how can we find that without creating a queue? So let's say if we just calculate the contiguous sequence of the character. So let's suppose we calculate how many times a occurs contiguously in single iterations. So here we found that A is appearing 2 times. So from this, we can say that this A would not be our spatial substring, because substring which contains only A has these 2 characters only. But in our case, we want substring to be at least of size k, 3. That means at least of size k, not at least, exactly of size k. So let's discard this. Let's consider B character and let's calculate the contiguous length of this substring which will consist B. So for why we are calculating only contiguous sequence of any character? Because we want all the characters in our substring to be similar. That means all the character in a substring should be equal. So for that, this contiguous sequence of the element we are calculating, and the length of that particular sequence, we will compare it with our k. So if let's say here we are getting the contiguous length of this B element, B character is 3. Is that equal to 3? Yes. So this will be our answer, because let's say if we are calculating a substring of size k, that means 3 here, then we are sure that the previous element of that particular substring would be different. Otherwise, we have already calculated. Otherwise, we have already included that in our contiguous count. As we have ended the sequence count here, that means the next element is not equal to this particular substring's character, right? So from counting the sequence of the contiguous characters which are similar, we are sure that the next element would be different and the previous element would also be different. So those satisfy these 2 conditions, that character immediately before the substring, it will be different because we are calculating the sequence of contiguous similar elements, and the character which is immediately after the substring would also be different. We just have to make sure about this first condition, that substring consists of, oh, not the first condition, because we already determining that through counting only the similar characters sequence. So this first condition is also satisfied, and we want our substring size to be k. So we will just calculate the size of this contiguous sequence of the elements. That means size of substring of this sequence of elements. That would be, if that is equal to k, then we can say that we found our answer. So we will let's take another example for better clarity. So let's say we have A, B, 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 C. So let's see, can we find a substring of length 3 as per our given conditions? So we can say that we cannot find that, because let's say if we have taken this substring which has all the similar elements in the substring, but the element which is next to it is also same. Element previous to it is not same, but this condition violates our this particular instance violates our the third conditions, which is element just immediately after the substring should not be similar character as any character in the substring. Okay. What if we take this as a substring? So here this also violates our second condition, that the character immediately before the substring should not be similar. So here we can say that in this particular substring, we would not find any of the substring which has length equal to 3. That means k, which has different characters in that neighborhood. How can we determine it through our algorithm? So let's find out the contiguous size of any substring which has similar character. So for A, we have 1, okay, that is not equal to K. So this is not considered. For B, we have 4, right? So this is also not possible because we need to find substring of length 3. That means K is equal to 3, which is not equal to this 4. Why? Why is so? Because if we pick any of the substring of length K is equal to 3 here, then the next character or the previous character will be similar because we have 4 contiguous B's. So if we pick any of the 3 consecutive B, then there can be one B which is lies behind previously of that substring, or it may lie after the substring. So our condition will be violated anyhow. So that was the intuition behind this problem. So let's move to our coding part. Okay, so let's first initialize our size variable, which would consist of the length of the string. Next, first initialize our q variable, in which we will include all the substring characters. Now let's iterate through all the character in this particular string. We will use enumerate here so that we will also get this index and character. We will append each character to this particular queue so that it suggests that for this particular character we are including it in our string. Here we have to make sure if our substring length exceeds the k, then we have to pop the leftmost element from our queue, because we want our substring length to be equal to k only. So consider this queue's character as our character in the substring. Now we have to determine what will be the previous character's index. That would be equal to index minus k. Let's say if we have k is equal to 3, then our the previous character, which is just before the starting of our substring, would be equal to index minus k. Let's say if we have current index as 4, then the previous index of this particular substring would be 4 minus 3 is equal to 1. So let's say we have a, b, c, d here, and we have 0 to 3 index. And if we are currently at third index, the current character is t, and if we have substring of length k is equal to 3, then the previous character would be 3 minus 3, which is current index 3 minus k. That means 0. Here it is a. So previous character we can get it through this particular operation, that is index minus k. What if we want the next character? It will be simply index plus 1. As you can see here, the next character is e, which is present at index 4, but our current index is 3. So the next character we can get it by index plus 1. Now we have to check if the length of our substring is equal to k, that means the length of our queue is equal to k. Then we also again have to check if all the characters in this particular queue are same. For that, we are creating a set of that particular queue, and we will check the length of that particular set. If it is 1, then this is the correct condition. This may be a correct solution if the previous and the next character wouldn't be similar to any of the character in our string. So let's check if the previous character index is valid. Let's say if we have to check if index minus k is even valid. If we don't have any previous character, then we don't need to check it. So here we are just validating if our previous character index is present or not. If it is less than 0, then it is not present. So for that case, we don't have to check it. But if that is not the case, and if we have previous character index is greater than or equal to 0, which means it is satisfying the condition, and if we have a character which is present just before our substring, then we will check if that particular character is equal to current character. That means any character in our substring. If that is the case, then this is not a valid answer. If we have previous character index character is different than our substring character, then that is the valid that can be the valid solution. Next, we will check if the next character index is greater than or equal to size. That means if we don't have next character present. So if that is the case, then we don't need to check the next character. But if that is not the case, and if next character index is less than size, and the next character is not equal to our current character, then we will just return true. Otherwise, we will just return false if neither of our substring of length particular k is not satisfying any of this condition. Let's check the solution. Okay, so we missed one column here. Okay, so let's simplify this. For simplification, I have mentioned each condition in a separate line to make code more readable. Okay, so this is working. So this was our total brute force solution, but let's move to more optimized version. That means let's reduce the time complexity of this particular solution. So for that, we will need a count variable, which we will use it for counting the contiguous subsequence of a single character. So let's let's initialize our count variable as 0 and let's enumerate through all the characters in this particular substring. Okay. So instead of enumerating, we will just going through all the indexes of this particular substring, and we will check if the current character is equal to the previous character, then we will increment our count variable. Otherwise, we will just set it our count variable to 1. So let's go through this for loop from uh, 1 to size of this particular substring. No, 1 to size of this string as if our current character is equal to previous character, then we will increment our count variable. To satisfy I minus 1, we will start our for loop from 1. So if the current character is similar to our previous character, then we will increment our count variable. We will also initialize our count variable to 1 because we are starting from the second character and we have already counted first character in our starting of the subsequence. So here we are considering that as this for loop will start from B, that means the second position, that means the first index. So we are already counting A as in subsequence, that means count is equal to 1. And then we will start our for loop to check the longest common subsequence. If that is not the case, if the current character is not equal to the previous character, then we will just set our count variable to 1. But first we have to check if the previous subsequence was equal to length k, then we will just return 2 because the length of the subsequence, that means the length of the substring which we found, was equal to k, and that's what we need. So we will just check the previous count of the length of the substring. If we found it to k, then we will return true. Otherwise, at last, we will just check if among the all sequences of this for loop, the last sequence which we found, we will check if the count is equal to 3 equal to k, then we will return it true. Otherwise, we will return it as false. The time complexity of this particular algorithm would be O of n because just we are iterating through all the characters here. Previously, it was n into k because we were using set and queue related operations. The space complexity here would be O of 1 because we are only using count is equal to count variable, which is a constant space variable. Other than that, we are not using queue or set related variables here. So space complexity would be O of 1 and time complexity would be O of n here. So that's it for today, guys. Thanks for watching. Catch you guys in the next one. Peace.